Good afternoon, guys. Welcome back into my channel. So in this lab, we're gonna learn how to configure EtherChannel. So EtherChannel is a very important topic and skills on Cisco network engineer. So there go the lab topology and there go the objective. So it says that configure basic switch settings, and part 2 is to configure an EtherChannel with Cisco PAGP. We're gonna configure an 802.380 and LSCP EtherChannel, and part 4 is to configure a redundant EtherChannel link. So if we were to speak more about EtherChannel, so EtherChannel is a port link aggregation technology in which multiple physical port links are grouped into one logical link. It is used to provide high-speed links and redundancy. A maximum of 8 links can be aggregated to form a single logical link. So this is a topology about EtherChannel architecture. So here's a topology in which 2 switches are connected with one PC, and each the link between the switches and PC is 1,000 megabytes per second, and the link between the switches is 100 megabytes per second. So as you can see, now suppose if you want to send traffic of 100 megabytes per second, then we have congestion as the length between the switches is of 100 megabits per second only, and packets will start dropping. Now, to solve this problem, we should have a high-speed link between the switches. To achieve this, we can simply replace the current link with a high-speed link, or we can bundle up more than one link of the same speed of 100 megabits per second. By forming an EtherChannel, you can bundle up more than one link into a single logical link. But as you connect the switches with more than one link, STP, just spelling tree protocol, will block the least redundant link. As we have made an EtherChannel, all the links that are grouped as one logical link will be treated as a single logical link. Therefore, no links will be blocked, and also it will provide us high-speed link and redundancy in our network. That's the criteria. To form an EtherChannel, all ports should have the same duplex, first of all, and the same speed, the same VLAN configuration. Native VLAN are allowed. VLAN should be same. Switch port mode should be the same access or trunk mode. Now, EtherChannel protocols. To form an EtherChannel, there are 2 protocols: port aggregation protocol, a link aggregation control protocol, or Let's just give this a little bit of space here. So port aggregation protocol, which is PAGP, the Cisco proprietary protocol, port aggregation protocol, is an EtherChannel technology. It's a type of data traffic load balancing that involves the logical aggregation of Cisco Ethernet switch port. A PAGP, which is port aggregation protocol, EtherChannel can merge up to 8 physical links into one virtual link. LSCP, or Link Aggregation Control Protocol, is an IEEE open standard. These are merely on. In this mode, the interface will be a part of EtherChannel, but not negotiation take place. Desirable, in this mode, the interface will continuously attempt to convert the other side interface into an EtherChannel. Although in this mode, the interface will become a part of EtherChannel if and only it is a requested by opposite interface. Off. No EtherChannel configuration on the interface configuration. Now, they're going another topology. This says there is a small topology in which this two switches, switch 1 and switch 2, are connected with each other, and we have to bundle these two links in single logical link. So that's basically the little lecture about EtherChannel. So let's not wasting time. Let's go ahead and pull up Packet Tracer and start configuring EtherChannel. So guys, there go the topology. Let's go ahead and make this bigger. Now we're gonna start with our configuration about EtherChannel. So last but not least, to configure the basic switches settings, assign each switch a host name according to the topology diagram. Now, before beginning the link aggregation between switches, we're gonna verify the existing configuration of the ports that connected the switches to ensure that the ports will successfully join the EtherChannels. We're gonna use the command to provide the information about the states of the switches port included. So first thing first, let's take a look at switch 1. Let's do enable conft and let's call it host S1. We changed the name. Now let's see. We do show interfaces. Do show interfaces include Ethernet. Now, checking all these ports. So now we see the only connection we have is the switches that are connected together. Now, we could do again, do show interface status. Now, guys, you could see the only connection we have is the two ports. gig 1 and gig 2 and fast Ethernet 20, 20, 21, and 22. Now let's check the chunk. You could say do show interfaces chunk. Now with Cisco packet traces, sometimes it's hard to display the trunk. Now, note that if the ports are configured with DTP, which is dynamic auto mode, and you do not set the mode of the ports to trunk, the links do not form chunks, and we mean access ports. The default mode on 2960, which is a switch model, is for DTP to be enabled and set to dynamic auto. So the DTP can be disabled on the interfaces with the switch port negotiation comment. Now, guys, on part 2, what we're going to do, we're going to configure an EtherChannel on the Cisco, PAGP. When configuring the EtherChannel, it's recommended to shut down the physical ports being put on both devices before configuring them into channel groups. Otherwise, EtherChannel misconfigured guard may place these ports into an disable state. So these port and port channels can be re-enabled after the EtherChannel is configured. So what we're going to do here, we're going to configure the port channel 1. The first EtherChannel that is created for this activities aggregated port 21 and 22, as we see between switch 1 and switch 3, configure these ports on both switches as static trunk port. So if we do show NFS trunk on port 1, it should display everything. Now, let's go ahead and start. On switch 1, we could do expand. No, let's do interface range F0 / 21 to 22nd. Okay, so this, do this, start doing this up. Let's do this and tab, see if we get it. Interface range, okay, let's do interface range, pass Ethernet. Oh, that was my bad. Should put 0 / 21 - 22. Okay, shut down. Now, the interfaces must be shut down before adding them to the channel group. Remember that. And then we could do channel group it does ticket channel group 1 mode desirable, right? So we created a port channel interface port channel 1. Now we could do no shutdown. And let's do the same for let's do the same for switch 3. Let's go ahead and pause. Let's close this. Bingo. Open. So enable conf T. Let's go ahead and change host. I'm sorry. Host S2. Nope. Host S3. Oh, S3. Okay, now we could do interface range fast Ethernet from 0/21-22. Am I right? What am I doing wrong? Interface range of 0. What am I doing wrong? What am I doing wrong? Let's see. So interface range, right? First. Oh, my bad. Okay, guys. Space. Right. Okay. Now we shut down, and then we could say channel group 1 mode desirable, and we could do no shutdown. No shutdown. So let's start let's exit out a little bit and start doing this again. So instead of no shutdown, we must have typed shutdown here. So let's opt out with this range, right? Then we could do no shutdown, no shutdown. See if it take it. No shutdown. So we good. Okay. So let's go back to switch 1 now. Now go switch 1, make this bigger. Oh, see if we had no shutdown. So we good. Okay. Now on switch 1, so now the message creating a port channel interface port channel 1 should appear on both switches. When the channel group is configured, this interface this designation will appear as PO1 in command output. So now we're going to configure the logical interface to become a chunk by first entering the interface port channel number, command, and then the switch port and the switch port mode chunk. So let's do this configuration. On switch 1, we could do interface. Oh no, let's X out 1. We could do ent port channel 1, and then we could do switch port mode chunk, right? Now let's go ahead and do the same for switch 3, right? Let's X out 1, and then we could do interface port mode, port channel 1, and then we could do switch port mode chunk. So now we're going to verify port channel 1 status and issue the show EtherChannel summary command on switch 1 and switch 3 to verify that the EtherChannel is working on both switches. So we already on switch 3. Let's just do exit out 1. We could say do show EtherChannel summary. Let's do some. Let's see if it takes it. Okay, so we lazy. Summary. It doesn't take it. So let's go. Oh, no. Let's go ahead. Oh. So my bad. I'm sorry, guys. So it says do. Oh no, we don't need do again. So show it some. There we go. So now you can see the flag is down and the P in port channel. So the I is standalone. So everything. So see where it says that number of port channel group is use one and number of aggregator is one. So now, if the EtherChannel does not come up and shut down, the physical NFS on both ends of the EtherChannel and then bring them back again, the show NFS trunk and show spanning tree comment should show the port channel as one logical link. Now let's go ahead and do the same on on switch one. Let's do exit one. So do show ether channel sum. So there we go again. Let's make swoop yes. Now, what we're gonna do is we're gonna configure the 802.3 AD LSCP ether channel. So in 2000, the IEEE released the 802.3 AD, which is an open standard version of EtherChannel and is commonly referred to as LSCP. Using the previous comment, configure the link between switch 1 and switch 3. We're going to use, so let's go ahead and do on switch 1, we already here. Let's do interface range gig 0/1 to 2, right? Shut down. And then we could do channel. We could do channel group 2 mode active. Oh, channel group 2 mode active. We could say no shutdown. Then we could do interface pop-up interface. Oh. Yep. Okay, so we could do interface port. Does it take it? So port channel. Oh, we gotta type all this command. 2 switch port mode chunk. Right? Now let's do the same on switch 2. Let's go on switch 2. Since we didn't get to switch 2 yet, let's do enable conf t. We could do host S3, right? So we could do interface range gig 0/1 to 2 shut down. Now we could do channel group 2 mode active. And we could do no shutdown. And then we could do interface, oh, it doesn't take it this one, interface port, I'm lazy, port channel 2 switch switch port mode chunk. All right. So now, guys, if you verify the port channel 2 status, let's use this command. Let's do show EtherChannel 8 sum. So now you will see that the number of channel group in use is 2. No, so let's check this on switch 1 instead of switch 2. See if it will change. Could say do show it sum. So it says, so number of channel group in use is 2. So we have it here. So we're in good shape. Now in part 4, guys, what we're gonna do, we're gonna configure a redundant EtherChannel link. You check here, you would see on part 4, it says to configure a redundant EtherChannel link right there. So we already done those 3 parts all together. Those 3 have already been done. So let's go ahead and do the part 4 on this lab assignments. What am I doing? So now on switch 2, let's go ahead. On switch 2, there are a variety of options for channel group, number, mode, and command, guys. So on switch 2, we could do, let's do an up arrow and see if, okay. So we got to X out 2 steps anyway. So let's try that. Exit. Let's do interface range F0/23-24. Then we could do channel group 3. Try that and see. So it says that the mode EtherChannel mode of the interface. So it doesn't display the lag, the LSCP unconditionally, and the auto and stuff like that. Mine on switch 2 or switch 3? Oh, this should be done on switch 2. What am I doing? Right? See. Should be switch 2, Carlo, not switch 3. This is the confusion here. So we should X out, make this host S2, not S3. As this one is already switched to A, am I correct? Let me see. Yeah, it's already switched to A, so we good. We're on the safe side. All right. So now, what we can do is, let's do on switch 2. Let's up our NFS range F0/23-24, no shutdown. Then we could do channel, see if we find it. Channel group 3. Let's make this mode passive, right? And let's open this port. No shutdown. Now let's do NFS port channel 3 Let's do interface port channel, oh, sorry, port channel 3 switch port mode chunk. Now, on switch 3, we're gonna add port F0, NFS 23 and 24 to port channel 3 with the channel group 3 mode active. And the active option is going to indicate that you want the switch to use LSCP unconditionally, statically configure port channel 3 as a trunk interface. So let's go ahead on so on switch 3, for switch 3, you could do enable conf t. Let's do interface switch F as Ethernet 0/23-24. Then we could do what? Switch port mode chunk, switch port mode, up, switch port mode chunk, and then we could do shutdown. Then we could do channel, we could do channel group 3 mode active, right? So it says creating a port channel interface. Then we could say no shutdown. We could do interface port channel 3 switch port mode chunk. So now, if we were to go on switch 2 and do a show it a channel summary. So to show it summary, I'll do show it summary. Okay, so you see here it says the number of channel in use is 2 and the number of aggregator is 2. We have the LSCP on those ports, which is good. So we good. So on switch one, guys, if we were to, oh, we on switch, okay, on switch one, say exit out. If we were to go, so do show spanning tree active. See if it's taken. Let's take it. So now you see how it says the VLAN 0001 spanning tree enable protocol IEEE, right? So port 27 is port channel, right? So port channel 2 is not operative because spanning tree protocol placed some ports into blocking mode. Unfortunately, those ports were the gigabit ports. In this topology, you can restore these ports by using switch 1 to be primary route for VLAN 1. You could also set the priority to 24/57/6. So let's do on switch 1, let's do spanning tree VLAN 1 root primary, right? Now you may have wait for spanning tree to recalculate the three topology, and you can press fast forwarding if necessary, and let's use the same command show spanning tree active, and you'll see now. So do show spanning, oh, spanning tree active. Then go. So now the EtherChannel has some specific guidelines that must be followed in order to avoid configuration problems. First of all the internet NFS support EtherChannel up to a maximum of 8 NFS with no requirement that the NFS be on the same NFS module. Second, the NFSs within an EtherChannel must operate at the same speed and duplex. Now, third, the EtherChannel link can function as either single VLAN access port or as trunk link between switches. All NFSs in layer 2 EtherChannel must be members of the same VLAN or the configuration as trunks. If configured as trunk links, layer 2 EtherChannel must have the same native VLAN and have the same VLANs allowed on both switches connected to the trunk. Now, the sixth rule, when configuring EtherChannel links, all NFSs should be shut down prior to beginning the EtherChannel configuration. When configuration is complete, the links can be re-enabled. Rule 7. After configuring the EtherChannel, we have to verify that all the NFSs are in up state. It is possible, Rule 8, to configure an EtherChannel as static or for it to use either PAGP or LACP to negotiate the EtherChannel connection. The determination of how an EtherChannel is set up is the value of the channel group number mode command valid values of active. LACP is enabled unconditionally. Passive LACP is enabled only if another LACP only if another LSCP capable device is connected. Now, desirable LAPAGP is enabled unconditionally. Now, the auto PAGP is enabled only if another PAGP capable device is connected. Now, the on EtherChannel is enabled, but without either LSCP or PAGP. Now, LAMP port can form an EtherChannel using PAGP if the modes are compatible. Compatible PAGP modes are desirable, more than equal to desirable, desirable, more than equal to auto. If both NFSs are in auto mode, an EtherChannel cannot form. Now, the LAN port can form the EtherChannel using LSCP if the modes are compatible. Compatible LSCP modes are active, more than equal to active, active more than equal to passive. If both NFSs are in passive mode, an EtherChannel cannot form using LSCP. Channel group numbers are local to the individual switch, although this activity uses the same channel group number on either end of the EtherChannel connection. It is not a requirement channel group 1, NFSP01, on one switch can form an EtherChannel group, channel group 5, NFSP05 on another switch. So guys, thank you so very much for following along with me. So EtherChannel is a very hot topic for Cisco's. On here real quick, make sure that we have everything that we had to do with it works in order in this sense. So we have, let's say, do show NBR, show, okay. What's name? Let's say NFS. Oh, exit out. So we could say NFS range F0/21.22. Then we could do what? Switch mode, switch port mode, we could do chunk. Let's see. And then shut down, right? Then we could do channel group, then 1. We could do mode desirable, mode desirable, no shutdown. And we could do interface port channel 1 switch. No. So we already do the desirable and no shutdown. So we go to okay. Switch port mode. Switch port mode chunk. Oh, chunk. Right. Then we could do interface range. We have to X out one more. F0/23, 24. switch up, switch up, switch, port, mode, talk. Right? Then we can do shutdown. Then we can do channel, channel group mode, channel group 3 mode, channel group 3 mode active. And you could do it. No shutdown. What do you do? We do interface. Interface, port, channel 3, switch port, mode, chalk. Now let's check our configuration. So we good. Yep. So we good. All right, guys. So thank you so very much for following along with me. Stay tuned for another lab. I appreciate you guys.